and we will continue on the track on securing the next generation of connectivity with Arkadiusz Czuba, who is a research and innovation engineer at IS Wireless, and so who is going to talk to us about scalability and resilience of terrestrial networks and non-terrestrial networks domains with disaggregated 5G LiquidRAN with the perspective of the EU-funded research projects. So over to you.
Thank you. Hello, everybody. I'm Arkadiusz Czuba. I'm from IS Wireless. We are developing and deploying ultra-resilient radio access networks. And today I will talk about the scalability and resilience in NTN and TN domains from the perspective of disaggregated RAN, in particular our product, and the also perspective of EU-funded projects like Sandbox, Network, and Micon. I will start from briefly introducing ourselves, what we are doing. Then I will talk briefly about the challenges in TN and NTN domains, especially of those what we are dealing with, so scalability and resilience. Then how the disaggregation of RAN is actually the solution for that, and how the EU initiatives actually are contributing and helping the development of such ideas into both those domains. So we are a Polish company founded in 2006. Now we have 2 offices in Netherlands and HQ in Poland. We are basically delivering the software-based, ultra-resilient, secure, efficient 5G and future 6G networks. And we participate in multiple 6G projects. We have patents of our technology, and we are deploying our solution worldwide. So the core of our product is the disaggregated software-based RAN. So we are deploying all of RAN components from radio unit, this decentralized unit, and centralized unit, and RAN intelligent controller in various hardware, commercial off-the-shelf hardware, and we are cooperating with external providers of SMO and the core network. The RU hardware of our partner is also supporting the NTN future deployment, and in terms of computing hardware, we are by now focusing on x86 architecture for processors, and we are compliant with many cloud-based vendors, but we also working on ARM porting of our software. So, as I mentioned, we are cooperating with NATO Diana initiative, and we are working closely with Polish MOD, and we also recently tested our solution in ORCID in US to have US market requirements done. So what are the challenges that we are facing in 5G RAN? Basically, when the solution RAN solution is centralized, for example, demand for coverage and for service is centralized, the capacity and expansion of network can be complex, slow to do adding new hardware. In non-terrestrial domain, for example, this is like the previous talk was also about. This is the classical bent pipe architecture. It's also centralized, so it can be affected by single attacks, and yes, the service recovery is then also slow because the wider part of the network is affected. So, what this aggregation of RAN can actually help us? So, in the terrestrial domain, we can split the the components of RAN into radio side, the edge devices, cloud services, and in non-terrestrial domain, there was also in the previous talk about the regenerative architecture. So the part of the or the whole GNOD can be deployed in the satellite. So it's spread among the NTN, TN and NTN domain. And what is the actual use case? For example, if we have attack or part of the system, for example, in TN domain, one CU and one data center was attacked, we can quickly move that part of the network to another instance. It's governed by the operation is governed by RIC, so RAN Intelligent Controller. In the non-terrestrial domain, for example, when we have some attack, the regenerative architecture is like not the itself the resilient for cyber attack, but it can reroute, for example, the traffic to another satellite. There is also a lot of challenges in the delay itself, but that's the idea of like the disaggregation can help us in deploying the part of the RAN on the satellite. Okay, so for example, how such resiliency can be deployed by disaggregation of computing. So here we have edge and extreme edge part of the network distributed among the devices. And for example, when part of the network is attacked, we can redistribute computing computational power and to the other devices to still provide the service and quality of service during the operation. And how actually the EU initiatives are helping to develop and test, more importantly, to test the scenarios, the mission objectives for such disaggregated architectures. The first project I want to introduce is the Sandbox project. Sandbox is about providing the experimental infrastructure as a service. So the basic idea is to here is to create experimentation facility to be used in Europe, and the Sandbox is providing the software library with, for example, various solutions, algorithms, etc. And with that, someone or some company or institute can deploy the solution it wants to test on the computing resources provided by Sandbox, and then deploy it on the physical infrastructure to test the solution. So Sandbox is one of the projects that is pioneering the large-scale testing of future NTN approaches. Also, it also provided it's also contributing with other projects, and yes, so this is the this example about supporting the NTN development and how it can be viewed in the in practice. So, for example, the algorithm we want to test on the trial network of Sandbox. We are going through the development stages, and for example, of RAN, we have XApp development, so the application for RAN intelligent controller, and it can be cybersecurity algorithm or traffic steering. Then we can deploy it on the physical infrastructure of Sandbox to test multiple scenarios or validate the idea. Then another project I want to mention is Network. Network is more about the algorithm and the cybersecurity. Network's goal is to develop the new way to bring cybersecurity for future distributed 6G networks and is really related, really deep into bring AI and distribution of the whole idea of cybersecurity, and the inspiration was mostly by actual immune system of the humans. So here, for example, the solution that is developed during this project. So imagine that we have like general RAN network and the two attacks, for example, jamming. So the signals from UE are disrupted, or we have DDoS flooding to the network, and with AI and optimization of the network with XApps in RIG, we can mitigate those actions and still provide the service of the network. And also that's for example also the solution we can test on the Sandbox environment. Okay. Next project I want to introduce is Mekon, and Mekon is about bringing. It's a new project, bringing the multi-access edge computing for 5G and future 6G. So here the idea is to unify TN and NTN networks to provide the coverage not only like selectively for TN or NTN, but treating it as like one unit. So for example, the traffic steering is one application where we have remote data center with our rig that governs the connectivity. And for example, the drone that is visible here, it can fly to the remote area without terrestrial coverage, and then we can steer the traffic over the NTN. So this is the example of the regenerative architecture, right? So we have part of the RAN deployed on the satellite, and the satellite then provides coverage for the drones, and if it's in the terrestrial zone, the terrestrial part is providing service. Of course, it's still in the simulation part. It's a lower TRL project, but that's the work that it's really necessary, and there is an interest in that. So what are also the directions of the EU from the research perspective? So in Horizon there is a need for alternative solutions for centralized platforms. Also, there was talk about earlier in the master room also about the sovereignty and the resiliency of the systems. And here we are also dealing with 5G and 6G solutions that can be more even more reliable, resilient. And in the budget of EU, there is spending on that. Also, the agencies of EU also are pursuing this this problem. So ESA, of course, is really interested in NTN part, so satellite and satellite-based connectivity, and from the defense perspective, satellite communication, reliable communication in defense, and robust and resilient 5G communication. Okay, so key takeaways from my presentation. The disaggregated infrastructure is something that we are interested in, but also the research and strategic movement. Because it brings modularity, scaling, and especially after the failure, fast recovery. Sandbox project is the experimentation core. So it provides the physical infrastructure and the software-based infrastructure for experimentation for Europe. And EU research projects drive the resilient communication. And also the MECON and network are bringing new solutions. And EU is pushing towards resiliency, sovereignty, Europe technological independence, and so on. Here you can scan the QR code if you want more information about the Sandbox project in these 4 areas. So NTN, reflective intelligence service, new frequency ranges, and deterministic networking. And that's it. You can find the information about me here. And thank you for your attention.
Thank you very much for your presentations. Are there any questions in the room? About maybe I will ask then one. So we had Giacomo from ESA that told us also about the challenges and the standardization that is currently in progress. How do you manage these in progress standardization with your own development?
Yes, we are following closely the 3GPP standardization, and we actually aiming for the compliance. So that's why we are more and more interested in NTN domain, as new releases of 3GPP actually are mentioning the regenerative architecture and more and more NTN basically. So we are working towards it. Okay.
So you will adapt then to the
yes.
new coming. Okay. So then keeping some modularity and not having fixed architectures, I guess.
Yes. Having the network disaggregated to be resilient for any attack, basically.
Okay. Well, quite challenging. Yeah. Thank you very much for your presentation again. And so on.